Hello, in this video I will be working through the Chapter 4 Quiz 2 practice version. So the first question is finding the sine of 5 pi over 3. Okay, let me zoom in a little bit. Well, first I'm going to think about where this is on the unit circle. Well, 5 pi over 3 is just 2 pi minus pi over 3. Right, because 2 pi is 6 pi over 3. So I know that it's going to be, I'm going to go to 2 pi and then go pi over 3 backwards. That's kind of how I'm thinking about it. All right, so if I were to go all the way to 2 pi, I would be here, and then I'm just going to go pi over 3 backwards. And pi over 3 is just 60 degrees. So that places me right here. Right, that's pi over 3 behind 2 pi. And then the coordinates of this point, I know the x-coordinate is going to be 1/2, because that's it's a short one. The x-coordinate is shorter than the y-coordinate, and it's positive. That's kind of how I think about it personally. And then the y-coordinate is going to be negative, and it's going to be root 3 over 2. So negative root 3 over 2. And then sine of pi over 3 is going to be the y-coordinate. So my answer is negative root 3 over 2. Okay. Alternatively, you could have drawn the triangle, and you would have seen that if the radius is 1, then because this is 60 degrees, then this length must be 1/2, and this length must be root 3 over 2. Next one, cosine 7 pi over 4. Well, 7 pi over 4, I know is just 2 pi minus pi over 4. And so on my unit circle, I can locate that right here. Oops. Right here. And then I know the coordinates of this point are going to be root 2 over 2 and negative root 2 over 2 for the y. I know it's root 2 over 2 because this is a multiple of pi over 4, or 45 degrees. And so there has to be a 45, 45, 90 triangle somewhere. And I know they're going to be the same. X and y are going to have the same magnitude, but I'm going to determine the signs based on which coordinate it's in. And so cosine is the x value, right? Cosine comes before sine. And so that means cosine 7 pi over 4 is root 2 over 2. Tangent 2 pi over 3. Pi over 3 is just pi minus, 2 pi over 3 is just pi minus pi over 3. So this is 120 degrees, or 60 degrees behind 180, which would be right here. Keeps doing that. Right there. And the coordinates of that point are going to be negative 1/2, comma, positive root 3 over 2. And so tangent is going to be sine over cosine, right? So it's going to be the y value, sine, which is root 3 over 2, divided by the x value, which is negative 1/2, and then that's going to be negative root 3. Next is cosecant of negative pi over 3. Okay, negative pi over 3 is pretty easy to find. That's just pi over 3 going clockwise around the circle, which is going to be right here. Oh my gosh. I don't know how to turn that thing off. The coordinates here are just going to be 1/2, comma, negative root 3 over 2. Okay? And then cosecant is equal to 1 over sine, right? So I'm going to take the reciprocal of my y value, which will be negative 2 over root 3 equals negative 2 times root 3 over 3, after I rationalize the denominator. Next is secant of 3 pi over 4. 3 pi over 4 is just pi minus pi over 4. So on my unit circle, that's going to be 135 degrees right here. Oh my gosh. Okay. The coordinates of this point are negative root 2 over 2, comma positive root 2 over 2. And, well, secant is just 1 over cosine, right? And my cosine is the x value, so I'm going to take the reciprocal of the x value, so 1 over negative root 2 over 2, which is negative root 2. Next, on the right side now, cotangent of negative 5 pi over 4. All right, well, negative 5 pi over 4 is just, there are different ways you could do this. You could either add 2 pi and you would get the same coterminal angle and the cotangent would not change. Or you could just do negative 5 pi over 4 is just negative pi and then minus another pi over 4. So this will be the equivalent of going pi clockwise in the negative direction and then extra pi over 4, right? So that will place me right there. So that's the negative 5 pi over 4 angle, and the coordinates of this point are just the same as what we just found. Negative root 2 over 2, comma, positive root 2 over 2. And so cotangent is 1 over tangent, or cosine over sine, right? Cosine over sine. So in this case, that would be the x value first on the top over sine on the bottom, which leaves us with negative 1, their cotangent. All right, sine 11 pi. Well, 11 pi is a really big angle, so what we're going to do is we're going to subtract a multiple of 2 pi, which doesn't change the value of sine, right, because the period of sine is 2 pi. We're going to subtract a multiple of 2 pi. We're going to choose 10 pi, because that's close to 11. Sorry. Sine of 11 pi minus 10 pi. This doesn't change the value of sine, and this is just sine of pi. Okay, so we're going to draw our unit circle, and pi is right there. The coordinates of that are negative 1, comma 0. And so sine of pi is the y-coordinate, so our answer is 0. Cosine 11 pi of 3. Well, we're going to subtract a multiple of 2 pi. I'm going to subtract by 4 pi, because 11 pi over 3 is pretty close to 12 pi over 3. So that leaves me with cosine of negative pi over 3, which is easier to find on the unit circle than 11 pi over 3. Okay, so negative pi over 3 is right here. Oh my gosh. Okay. The coordinates of this point are 1/2, comma, negative root 3 over 2. And so cosine of negative pi over 3 is 1/2. Tangent of pi over 2 is next. Well, pi over 2 is 90 degrees on the unit circle, so that's right here. Coordinates are 0, comma 1. Now, tangent is sine over cosine, right? And sine over cosine in this case is going to be the y value over the x value, which is 1 over 0. So tangent pi over 2 is undefined. That's our answer. Last one, cosecant of negative pi over 4. Negative pi over 4 is going to be in quadrant 4 right here. Oh my gosh. I'm going to turn that off in the settings later. And the coordinates of this point are positive root 2. Positive root 2, comma, negative root 2 over 2. And so cosecant is just 1 over sine, right? And so we're going to take the reciprocal of the y-coordinate, which is negative root 2. okay? Right, because that's 1 over negative root 2 over 2, which is, you can confirm, negative root 2. Okay, next question. Given tangent of theta is 5 over 6, and theta is between 0 and 90, find the values of the other 5 trigonometric functions of theta. So for this question, we are able to draw a right triangle. And the reason is because this is an acute angle. Okay, so we're going to draw a right triangle. This is theta. And because tangent is opposite over adjacent, this could be 5, and this might be 6. Okay? So next we need to find the hypotenuse, which we can do with Pythagorean theorem. 25 plus 36, take the square root of that. That leaves us with the square root of 61, which is not simplifiable. So now we can quickly write them. Sine theta is opposite over hypotenuse, so that's 5 over root 61, which you'll need to rationalize as 5 root 61 over 61. Cosine theta, very similar, 6 over root 61, which I rationalize here. Cosecant of theta is just the reciprocal of sine, so that's root 61 over 5. And secant theta is the reciprocal of cosine theta. Finally, cotangent is the reciprocal of tangent, which is 6/5. Next question has me prove an identity. So my goal is to simply use the relations I know, which are that sine squared theta plus cosine squared theta equals 1, and tangent theta equals sine over cosine, and use these two relations to make the left side equal to the right side. So my first step, I'm going to replace 1 minus cosine squared with sine squared. That's just the Pythagorean identity. That leaves me with 1 over sine squared theta is equal to, and then on the left side, I'm going to try to write this in terms of sine and cosine. Secant is 1 over cosine, so I have 1 over cosine squared theta times cotangent squared, which is just cosine squared over sine squared. The reason being cotangent is 1 over tangent, and tangent is sine over cosine, so cotangent is cosine over sine. And so the right side simplifies, things cancel, and I'm left with 1 over sine squared is equal to 1 over sine squared, and I'm done. Okay, next one. If sine alpha equals negative 5/8 and alpha lies in quadrant 3, then evaluate the following. Okay, remember quadrant 3 is this one. So the third quadrant. So I'm going to start by drawing the unit circle for each of these questions. Sine pi minus a. Well, if you remember from class, sine pi minus a is equal to sine pi minus alpha is equal to sine of alpha. That's a relation that we derived. The reason is because pi minus alpha is just a reflection across the y-axis. So if alpha is here, then here is pi minus alpha. It's something you can check for yourself. So because sine pi minus alpha is equal to sine of alpha, then that means this is negative 5/8. We also learned that sine of alpha plus pi is equal to negative sine of alpha. The reason is that on the unit circle, if this is alpha, then alpha plus pi is just a reflection across the origin. Right? You can imagine we're just going pi radians further. And so that flips the sign of the y coordinate, doesn't it? and the y-coordinate is the sine alpha. And so sine alpha plus pi is equal to negative sine of alpha, which is 5/8. Cosine alpha is something that we can only find using the Pythagorean identity. So cosine alpha squared is equal to 1 minus sine squared alpha. And so cosine alpha squared is 1 minus 25/64. Okay, which is equal to what, 39/64? Hope that's right. So that means cosine alpha is equal to plus or minus square root of 39/8. Now, we don't know whether it's plus or minus yet, but we can deduce based on which quadrant that alpha lies in. So because we know that alpha lies in quadrant 3, right, all the x-coordinates for quadrant 3 are negative, and cosine is the x-coordinate, right? So that means cosine of alpha is negative. So our answer is negative root 39/8. Next question, cosine pi over 2 minus alpha. Here we just use our cofunction relationship, right? Cofunctions of complementary angles are equal. So this is equal to sine of alpha. And we're done. Negative 5/8. Okay. Next, sine of alpha plus 2 pi. This is also equal to sine of alpha, because sine has a period of 2 pi, right? So it's going to repeat itself after we add 2 pi, which is, so this answer is negative 5/8. Next question. For each question, find two values of theta between 0 and 2 pi that satisfy the equation. Okay. So here we're going to want to use our unit circle. If sine theta is equal to negative root 3/2, then that means our y-coordinate must be negative root 3/2, right? And so that's somewhere here. Negative root 3/2 is around here. And so that means the point must be these 2 points. And so we know this point here is going to be pi plus another pi over 3, right? You can imagine we're going pi around the circle and then another pi over 3. Pi and then another pi over 3. So that leaves us with 4 pi over 3. This one is basically just going to be 2 pi and then going pi over 3 backwards, right? It's like going 2 pi and then going backwards by pi over 3. So that leaves us with 5 pi over 3. So those are going to be our two values of theta. Next one, tangent theta equals root 3. Okay, this one's a little more tricky. Well, tangent theta can only equal root 3 under two circumstances. The first is if sine theta equals root 3/2, and cosine theta equals 1/2. Right, you can confirm that sine theta over cosine theta would be root 3. The second possibility, if they're both negative, but the same magnitudes. So sine theta equals negative root 3/2, and cosine theta equals negative 1/2. Okay? So we're going to go to our unit circle and figure out which points those are. So for this one here, we're looking for a point that has an x-coordinate of 1/2 and a y-coordinate of root 3/2. And that's going to be right here, right? And that's pi over 3. Here, we're looking for a point that has an x-coordinate of negative 1/2. and y coordinate of negative root 3 over 2, which is going to be right here. And that's pi over 3 plus pi, or 4 pi over 3. So those are our two answers. The next question has us determining the quadrant in which theta lies. The first condition has sine theta is greater than 0 and secant theta is less than 0. Well, secant theta is less than 0 just means cosine theta is less than 0, right? Because secant is the reciprocal of cosine. And so that means we need a coordinate, or we need a quadrant where the y coordinates are positive, y is positive, and x is negative. Somewhere on the unit circle where y is positive and x is negative. Okay? And clearly if y is positive, it must be somewhere up here. And if x is negative, then it must be somewhere here. So that tells us that it's in quadrant 2. Second question has tangent theta less than 0 and cosecant theta less than 0. Well, if cosecant theta is less than 0, then that means sine theta is less than 0, right? And tangent theta is less than 0 tells us something a little different. It tells us that sine and cosine have different signs, okay? Because if sine and cosine are both positive, then tangent is going to be positive. But if sine and cosine are both negative, then tangent is also going to be positive. It's because a negative number divided by a negative number is a positive number. And so that tells us that sine and cosine have opposite signs. In other words, the x and y values have opposite signs. So, but this condition tells us that y is less than 0, right? Because sine is the y coordinate. And so if sine and cosine have opposite signs and x and y have opposite signs, then that means x must be greater than 0. So that puts us in in quadrant 4. Y is less than 0 and x is greater than 0. Well, I guess that's the last question. So that concludes this video. Thank you for watching, and take a look also at some of those extra practice problems in case you found any of these challenging.